uh, geothermal energy. So would say to to get the heat underneath the earth. That is a very basic principle. Okay, and in that, what we are trying to do, we try to dig our specific land area, and then, of course, with a certain depth of length. Okay, and yet afterward, we get the higher temperature from there, and then we try to extract all the heat to be transferred to the outside and use the heat for our application. For example, for the space heating, for example, for the hot water, or perhaps maybe due to the high temperature, we can convert directly as a steam to to for our turbine or power plant um, sources. Okay, so that's the basic related to the geothermal. In Malaysia, I would say fortunately, we do not have the geothermal. I mean, we are using the geothermal for the purpose of producing energy, because what we have that until the extent of the pool heating, pool heating, kolam air panas, pool heating. So that for the recreational, for those who are want to getting bath for the hot water. So in Malaysia we have that one, but until not the extent of producing as a part of the source of energy to power up your power plant or steam turbine or etc. Okay, normally this kind of environment, um, I would say, based on the geographical condition for that particular country. And Malaysia is not one of it, which is have a very huge of source of geothermal compared to other country such as US. Okay, US they have the mountain, hill, everything, which is all related to the fossil, the decay, or the things for the last 100 years or more than that. So then the things become part of the source of the geothermal energy. Okay, so I think that is a very basic related to the geothermal. For Malaysia, we are not go into that detail in terms of the resource, in terms of the technology, because in current situation, we are in the country that do not have much this kind of resources. Okay. In this content as well, we will try to discuss what is the advantage, disadvantage of having the geothermal, of course, the method or the approach, how they try to extract the energy underneath the earth, and yet what is the process. Okay, so we will try to look afterward related to the geothermal in Malaysia specifically. Okay. Source of Earth's internal energy, okay, 70% from the decay with long half life that are embedded within the Earth. Okay, so all the decay, everything, right? So for the last maybe 100 years, okay? And then some energy is from residual heat left over Earth's information. Okay, so we know that the movement of the Earth. Okay, so by having that kind of phenomenon, they store all the heat underneath the Earth. Uh, the rest of the energy come from meteorite impacts, which is have the particular uh, rock or material underneath that can be generated as a part of the energy. Okay, so different geothermal energy source, we can divide it into the hot water reservoir and also the geopressure reservoir. Okay, normal geothermal gradient, hot dry rock, molten magma. Normally, it's one part of the mountain. Okay. So by having this hot water reservoir, sorry, uh, hot water reservoir, the name implies the reservoir of hot underground water. There is a large amount of them in US. Okay, so because US are the most, I mean, the country that been used or utilize the geothermal quite huge in terms of the production. They are suit for the heating rather than the city production, meaning that they just get the hot water straight away without converting to other form of energy such as electric. They just go straight away for the application of the hot water in terms of the hot water reservoir. Okay, natural style reservoir is the case of hole dug into the ground can cause steam to come to the surface. So in the form of the steam. This type is also rare in the US. Okay, so meaning that some of the water still in form of water, but some of the area in form of steam. Okay, which is quite hard to identify which part of the land or geothermal area that produce at the end product as a steam reservoir. But then if you manage to get that one, you can be a tank or storage that can have the so that you do not have to convert from the water to the steam. You just directly use the steam or you use agriculture, the wood and rock, and that resource can be used both heat or natural gas. So it, okay, so that's the thing. That's the root of the geothermal source. Yet, normal geothermal gradient, okay, at any place in the planet, okay, there are normal temperature gradient plus 30 degree per kilometer dark in the earth, meaning that the more deeper you go to the uh, center of the earth, so meaning that you may go for the higher temperature. Okay, so by having this kind of reference, 30 degree per kilometer, 1 kilometer will give you 30 degree temperature. Okay, so depends how far you want to dig, and so that will give you higher temperature accordingly. There is a one dig at the 20,000 feet temperature will be about 190 degrees C above the surface temperature. The this one will be enough to produce electricity. Okay, so depends what's the application you need to do for that kind of approach. If you plan your system, should be get targeted temperature, for example, 200 degrees C. So you may go for that kind of uh, complexity by digging your into earth almost up to 20,000 feet inside the earth. Okay? So it depends. What is your application? It's not necessarily to have the specific temperature operation, but there you are the one who decide which kind of temperature you want to get so that you may go for the depth of the digging activity. However, more useful and economical technology has been developed to extract this large source of energy. Okay? So if, with the same approach by digging using the well, okay, and then is they are claim that more useful and economic technology. Okay? So it's a very conventional technology, just develop well and then try to a certain depth of um, in land and then try to produce that temperature. Hot dry rock, this type condition exists 5% in US, is similar to the normal gradient, but gradient is 40 degrees kilometer dark underground. Okay, so hot dry rock. Okay, so this one. And then molten magma. Okay, not only exists to tap into the heat reserve stored in magma. The best source for this is US and Alaska in Hawaii. So there's a lot of potential based on the geothermal energy, but then it's very dedicated to the process or the geopolitical effect. It's not relatively blessed to all countries. So some of the countries have the advantage of using solar. Some of the countries have the advantages to use the hydro. Some of the countries may be more efficient or useful to have the geothermal. So that's the thing that we need to consider because we need to know this kind of consideration. We are not go for all RE applicable for that particular or dedicated cases. So we as a student, we should learn this kind of subject, should able to identify, to know, to aware what is the most suitable application RE sources for that particular uses of perhaps country or industry. Okay, yes? So bear in your mind on that cases of concern. Okay, so this is the direct use of geothermal energy is appropriate for sources below 150 degrees. So if you still imagine, we have the solar thermal, which is in the form of the hot water and also for the space heating. So it same goes to this kind of approach, just the method. The initial source is from geothermal, but the end product or end result is still producing either the hot water or the hot air. Okay, which mean, but of course, they've given the different range of the temperature in terms of the hot water or the air, but then the application still remain the same, which is space heating, air conditioning system, industrial processes, drying, greenhouses, agriculture, hot water, research posts, and nothing more. Okay, so it more or less the same with the application of the solar thermal collector, which is produce the hot water or hot air for this form of application. Okay. But of course, this geothermal offer higher temperature. Okay, higher temperature. High temperature means a higher temperature compared to the solar thermal. Okay. How direct uses work? Okay, so as I mentioned previously, direct source function by sending water, okay, by sending water down to well to be heated by the earthworm. Okay, so we well land and then we try to put the circulation of water, okay, and then with the tap or with the cold water from the beginning, and then downstream to the well, and then coming back, come out from the water with hot water, and then try to store and try to circulate everything so that we can easily harvest the hot water from the underground. Then a heat pump, okay, as I mentioned, heat pump is used to take the heat from the underground water to the substance that is to the house. Then after the water is cooled, is injected back into the meaning that when they are trying to come out from the underneath of the earth, they are going up, and then of course they go for the heat exchanger approach, which is try to transfer all the heat that is absorbed underneath earth, and then after a certain period of flow length of the pipe, then they are going back as a cold water and go enter back the system. Okay, so that's the basic. So can try to draw this one. Okay, let's see. Okay, so it more or less like this. Let's say we try to change the color. Easier for you guys to look. Sorry. Okay. Let's say this is the downside now. Downside. So they try to go part time over here, which is the deeper, which is high temperature produced. Okay, temperature produced. Okay, then temperature produced. Then after they get the hot water, then they try to then transfer back, okay, transfer back, and then go to, from the ground, and then go to the tank, the part of the heat exchanger. Okay, and then from the T high, okay, and then after this one, come out with the T low, temperature low, okay, and then going back to do the circulation and the continuous running will accumulate the temperature over there, which is maybe the storage tank, the storage at least 35 at the start, for example, and then this from this circulation keep on running and increase to your desired temperature. Okay, so you aim to get 80, 50, 70, 90, so it depends. Okay. So this one is the meaning of the injected back to the earth. Injected back means that the cold water will be injected back to the in the. It's a very straightforward and simple process. And then this the ground heat collector. Okay, some of the houses using this kind of approach to heat up their house because of course due to the maybe during the cold season perhaps. Okay, so they try to get this kind of approach by having this kind of method. The system use horizontal loop in circulating water at depth of 60 to 160 centimeter. Okay, only 1.5 meter underground. Okay. So this one, same concept. Borehole heat exchanger, that one is 1 or 2 underground, with people look that is not 150 meter below. Okay. So, but I think one of the issues related to this kind of approach, I think we as a personal people, I mean public, do not have that facility, right, to dig that kind of depth inside 150 meter. Yeah. For this 150 cm also, okay, I think maybe we can try lah. 160 meter, which is 160 meter. What 1 meter? So it's like digging your grave lah. Yeah. Okay. So until that. So what about the 150 meter below? So there's no logic to be done by the personal or public. So you have to pay for the machine or the well and digging facility. Actually, you can try to implement this kind of approach. Okay? The heat pump, everything. Okay? This one is the purpose of the space heating, okay? The floor heating. This one. Okay? And the floor heating. They just do want to increase the temperature in the house so that to make this kind of circulation, this kind of circulation, this one, this one, this one. Okay. Just flow underneath your floor mat, okay, and then going back to the system, okay, to get to produce the hot environment in the form of water or in the form of air. Okay. So, the best, more appropriate for the utilization of solar thermal in the form of the useful heat of water or useful heat of air. But for the generation electricity from the geothermal greater than 150 C, so this method they be used to get kind of range. Dry steam plant, okay, dry steam plant. They were the first start to calculate to use underground steam value to calculate. So basically, so this is the picture. Okay, so production air, okay, to the side, okay, and then begin with the steam installing, and then go to convert to the generator and go to the load. Okay, and then the accessing water that maybe condensed through this kind of turbine we float on site and then go as a part of the hot water, and then after that certain length they convert from the hot water to vapor or steam, and then they have the due to the buoyancy effect, then they go certain way, and then the situation is continuous running. So that's the basic principle of having the to create the energy from geothermal. But then it's a very simple. You have the heat, and then the heat you convert to the steam to power your turbine, and let go to convert by the generator to produce the electricity to power up the load. It's a very basic okay? And then next, we go to okay. 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 Next, flash drive. Common cut. Usually is temperature of 60 Fahrenheit or more to the surface. This water is transported into the chamber, and the result can stay wet. The remaining water can still added in the bed to the source from which the water. So comparing to the previous one, so we are using the same approach, flash steam water pump. Okay, so we try to go to the generator as well, and so the rock layer. Rock layer means that 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 particular area that able to produce higher temperature. Okay, rock layer. So flash steam problem is that they have some sort of flashing over here. So flashing over here. It's a part of the airflow, okay, to get the turbine to power the steam. This one, a secondary cycle plant. The system pass moderately hot geothermal water, pass a liquid. Okay. Usually an organic is a lower boiling point. This resulting from the organic liquid. Turbine is processed to produce the emission water particle before the water lower than the H2 part. Okay. So they have the additional part of the in terms of the heat exchanger, I would say heat exchanger. So they have this kind of circulation. Yeah. And then they also have this kind of circulation uh, with the same approach to power up the turbine, the generator, and so that's the basic related with the binary cycle. But that's the next you mentioned just now with the steam and human principle. Okay, just a matter of the process, the complexity of the process depends on what you are looking for your dedicated or your expected temperature output or power generation you target. Okay, so hot dry rock. Okay, so this one, the simplest model of one injected well and two production well. So injected well and two production well. Pressurized cold water is sent down the injection well with hot to the water up. Then pressurized water of temperature greater than 200 Fahrenheit is brought to the surface and passed near a liquid with a lower boiling temperature, such as an organic liquid like methane, to ensure stream from the turbine. Then the cold water is injected. Okay, so this circulation and continuous running. Okay, does not produce any emission. The turbine must stay on making time to commercialize this new technology. Okay, then the cold water is injected. So this one is one of the approach to produce the high temperature, okay, greater than the 200 Fahrenheit, brought to the surface and pass near a liquid with a lower boiling temperature. Okay. So by having the low temperature, feature is that they easily to be converted, okay, to become a vapor, so that they can convert it to become a part of source of steam power plant. Uh, so far so good there. You take all the question. Okay, so maybe we try to look one of the second um, video related to the topic. Okay, I'll try to show this one.
If you've ever nope.
Can you hear my voice? Yes. And can you guys see the video? Okay.
Energy 101. If you've ever observed an erupting volcano or the geysers at Yellowstone National Park, you've seen geothermal energy in action. The Earth's crust is made of rocks and water. Deep below that is a layer of hot, molten rock called magma, which is even hotter than the sun's surface. The heat just over 6 miles below the surface contains 50,000 times more energy than all the oil and natural gas resources in the world. Releasing a small amount of that heat in the right way can create electricity. A well drilled a couple of miles deep can capture the rising hot water and steam. That steam spins a turbine, and a generator produces electricity. Geothermal is one of the least explored sources of renewable energy in the US, and most of us probably don't spend much time thinking about it. But since it's a pollution-free, renewable source of energy that's consistently reliable, at least it has been for the past 4.5 billion years, maybe we should. Hi, I'm
Okay, guys. So this is the next video. So I want to share you guys.
Planet Earth. It's hot and full of energy. If you've ever observed an erupting volcano, sat in a geothermal hot spring, or visited the geysers at Yellowstone National Park, you've experienced geothermal energy. The deeper you travel into the Earth, the hotter it gets. The Earth's crust is made of rocks and water. Underneath the Earth's crust is a layer of hot molten rock called magma, which is even hotter than the sun's surface. This Earth heat, also called geothermal energy, is a clean, renewable source of both power and heat. The energy from less than 10 kilometers deep contains 50,000 times more energy than all the oil and natural gas resources in the world. Globally, geothermal currently generates enough electricity to meet the needs of 60 million people. We can harness this vast energy by developing geothermal power projects, or geopower. Using today's technology, we can locate and drill into the geothermal resource at only a few kilometers deep and capture the rising hot water and steam. Releasing a small amount of that heat in the right way can create electricity, and the formation water is re-injected back into the same reservoir underground to be reheated and recycled. Binary turbine power plants use hot formation water to vaporize another fluid. The second fluid drives a turbine and generator to produce electricity. This closed-loop system produces no emissions and has one of the smallest environmental footprints of any power supply. Geothermal plants provide power 365 days per year, 24 hours per day, and projects are designed to operate a minimum of 20 to 30 years. It's clean electricity delivered via power lines to your community. GeoPower has a project goal to develop a 15 to 20 megawatt energy power facility. This is enough to provide clean, renewable electricity for over 15,000 homes. The advantages of geothermal do not stop at clean power. The geopower facility's waste heat can be used for a variety of community applications, including district heating for greenhouses, hot spring bathing, fish farms, and timber drying, to name just a few. By harnessing our Earth's heat resource, we can create a clean, renewable energy project that can grow your community today and create an ideal model for energy development for the next generation of Canadians.
Okay, guys. We go for the last video.
Successful advertisers for the past 200 years. Cal Energy's geothermal power plants. Unlike other power plants that rely on coal or other fossil fuels to create electricity for homes and businesses, geothermal power plants use superheated fluids from the Earth's geothermal resources to one of Cal Energy's geothermal power plants. Unlike other power plants that rely on coal or other fossil fuels to create electricity for homes and businesses, geothermal power plants use superheated fluids from the Earth's geothermal resources to generate electricity. The natural heat of the Earth creates geothermal resources. This heat comes from molten rock called magma, located at the Earth's core, deep below the geothermal resource. Over thousands of years, rainwater seeps through cracks in the Earth's surface and collects in underground reservoirs. The magma heats the water until it becomes a superheated fluid. To reach the superheated fluid, wells are drilled 5,000 to 10,000 feet below the surface of the Earth. These wells, called production wells, bring the superheated fluid to the Earth's surface, where it can be used to generate electricity for homes and businesses. This geothermal power plant uses crystallizer reactor clarifier technology, a process that turns the geothermal superheated fluid into steam while removing solids from it,
The steam is used to drive a turbine and generate electricity. All remaining geothermal fluids are injected back into the reservoir for reuse. Under its own pressure, superheated fluid from the geothermal resource flows naturally to the surface through production wells. As the liquid flows toward the surface, the pressure decreases, causing a small portion of the fluid still within the well to separate or flash into steam. At the surface, the superheated fluid and steam mixture flows through surface pipelines and into a wellhead separator. Inside the separator, the pressure of the superheated fluid is reduced. This causes a large amount of the superheated fluid to rapidly vaporize and flash into high-pressure steam. The geothermal fluid that is not flashed into steam in the wellhead separator flows to the second vessel, called a standard pressure crystallizer, where an additional amount of standard pressure steam is produced. The flash process continues in the low pressure crystallizer. The remaining fluid is again flashed, this time at a lower pressure to produce low pressure steam. All of the low pressure, standard pressure, and high pressure steam is delivered to a turbine. The fluid that is not flashed into steam flows into the reactor clarifier system and is then returned to the geothermal reservoir through injection wells. Turbines are the primary piece of equipment used to transform geothermal energy into mechanical energy. Pressurized steam created from the geothermal superheated fluid flows through pipelines to large steam turbines. The force and energy in the steam is used to spin the turbine blades. The turbines turn a shaft directly connected to an electrical generator. An electrical charge is created when magnets rotate within the generator. Large copper bars carry the electrical charge to a step-up transformer outside the plant. Within the transformer, the voltage is increased before the power is sent to the power lines that carry it to homes and businesses. Geothermal energy is a sustainable resource because with proper management, a geothermal resource can remain a renewable source of energy. Water trapped deep within the earth will naturally replace the superheated fluid that is drawn from the geothermal resource through surface wells. However, it is possible to deplete the geothermal resource by removing fluid faster than it can be naturally replaced. To help prevent this, the steam used in the geothermal power plant passes through a condenser that turns it back into fluid. At this stage, it's possible to recover minerals from the geothermal fluid before it's injected back into the earth. This condensed fluid, along not flashed to steam, is injected back into the underground reservoir. Magma naturally reheats the fluid so it can be used again.
Turn your sound up. You're going to want to hear this. That's the sound of a brand new 2020.
So let's have a look today at a binary type geothermal power station. Let's start where the process starts, and that's at the bottom or deep into the earth. We can see the red area here. This signifies heat. The Earth's core is around 5,000 to 7,000 degrees Celsius, and that heat from the core is radiated outwards. When we get to this point here, it's going to be several hundred degrees Celsius. And above that, if we have a porous or a semi-permeable aquifer, we're going to be able to store some water. So the water is going to be stored in the aquifer, and the water is going to be heated up by this heat being radiated outwards from the core. Now, some of it might turn to steam and some of it will stay as liquid. We actually call this a water-dominated reservoir. But let's just imagine for a moment it's entirely water-based or water-filled, because about 90% of all geothermal resources use water-dominated reservoirs. And let's imagine that water is then going to enter through this red pipe here and it's going to go up this red pipe, which we're going to call our production pipe or our production line, and it's going to end up at this valve here. The valve that I'm indicating now is called the production well head. Now the fluid, the geofluid, or the hot water comes out and it goes into a heat exchanger. That's this large grey item you're seeing in the middle of the screen now. Now the heat exchanger exchanges. Let's just finish up with our geofluid first. So the hot water comes in along here into the heat exchanger, and then it comes out of the orange pipe here and goes back in. This valve here is called the injection head valve, and we're going to go down now, and you can see the injection pipe, the orange one, goes all the way down, and it goes back into our water-dominated reservoir. Okay, so that's more or less all that the geofluid does. It comes up as a very hot fluid in the red pipe, and it goes back down into the water reservoir at a slightly lower temperature. But it exchanges the heat in the heat exchanger here. And the working fluid that's in this yellow here and here is normally going to be something with a low boiling point. Now the reason for that is because as the fluid, the working fluid, comes in here, it's coming along this pipe, it goes into the heat exchanger, it's then going to be heated up by our geofluid, it's our hot water, and then it's going to turn to vapor. Now if it has a low boiling point, it's going to turn to vapor at a lower temperature. This is very useful because the geofluid used for binary type geothermal power stations has a much lower temperature than the geofluid used for other types of geothermal power stations. Normally, for a plant like this, you'll have something like propane, isobutane, or maybe an ammonia water mixture, and these have low boiling points. You might even have some form of refrigerant, but perhaps not. But all of these have low boiling points, and they're going to turn to vapor when they're heated up by the geofluid, and then you're going to get this vapor coming out of the yellow pipe here, along here, along there, and into a turbine. Now this turbine is very large for the application that we're using it for here, but it's more for demonstration purposes. And the vapor as it goes in is going to drive the turbine and cause the turbine to rotate. As the turbine rotates, it's going to drive a generator, that's this item here. And as the rotor inside the generator turns, we're going to generate electricity. So we've now used the vapor for what we want to use it for, and we've generated some electricity. We go around the opposite side, we now need to condense the vapor and get it back out again so we can pump it. So it comes out through a condenser, that's these two yellow pipes here, and it's going to go. So it's being cooled down underneath the turbine, it's being turned back into a liquid, and then it's going back into our heat exchanger. That's essentially the entire process for this working fluid. So we'll heat it up, comes out as a vapor, goes to the turbine, is cooled down after it's done its work, and then is pumped back through the heat exchanger, and the process continues all over again. Now you might ask yourself, what's cooling down the working fluid then? What's enabling it to condense? Well, we'll use a cooling tower like this one here to cool down the vapor. And what's going to happen is we're going to have a cooling water circuit. And imagine for a moment you've got water in the bottom of the cooling tower. It's in this area here. And we can draw it out from the bottom of the cooling tower. And we'll take it along this blue pipe and all the way to a condenser. We'll cool down the working fluid vapor. It'll come back out here. Look along this pipe, along here, and into the top. It goes into the tower, and then we'll cool the cooling water down with the air, and then we'll send it back to the turbine again. So essentially what's happening here is we're having a series of heat exchanging operations. We need to get the geofluid out of the ground, and it's going to be hot. We're going to use some of that heat to heat up the working fluid and turn it into a vapor. Then we're going to send the geofluid back into the ground. The working to get it pumped back to the heat exchanger again. And in order to cool it back down again, we're going to use the cooling tower. That essentially is the way that a binary type geothermal power station works. It's interesting to note that this was actually the first ever type of geothermal power station used. The first ever power station, or geothermal power station, was actually built in Italy about 100 years ago. But the reason that this type of power station was used back then is because the fluid you get out of the ground is often corrosive, or it can be quite corrosive, and it can also scale. In other words, you'll end up with a thin film of sort of hard material that builds up on your turbine. And this all creates massive problems. So in order to get around these problems, you just have a heat exchanger. You exchange the heat within the heat exchanger, and then you use a nice clean fluid to be the working fluid. And that's the one that drives the turbine and won't damage the turbine because it's not corrosive and it won't scale or anything like that. The other big advantage with a binary type geothermal power station is that you can try to keep the liquid always as a liquid. And what I mean here is when it comes out of the ground, it's going to be a liquid if you put it under pressure. And this is quite useful because if it's not a liquid, if it's vaporizing off or if it's flashing off, then putting the hot geofluid here under pressure, you can keep it as a liquid and you prevent scaling, or at least minimize it as much as possible. The other massive advantage with a binary type geothermal power station is that you only need a fluid to come out of the ground at 80 degrees or 70 degrees, whatever, and not 100 degrees. Now, if you're using water and turning it to steam, you need a minimum of 100 degrees. So the geofluid has to come out of the ground at 100 degrees minimum, ideally a lot more. Whereas a binary type power plant, because we're using a different working fluid like propane or isobutane, we can have geofluid coming out of the ground at about 80 degrees or 70 degrees, and it's still going to turn our working fluid to a vapor. So we're still going to be able to use that to drive a turbine. That's not true if our working fluid is water. And there is a lot more geofluid in the ground at 80 degrees Celsius than there is at 150 degrees Celsius. And that means we've got a lot more opportunity to install binary type geothermal power stations than we have with the other two types of geothermal power station, or the main two types. Anyway, that's how a binary type geothermal power station works. And in the next video, we're going to explain the differences between all three types of geothermal power stations, or the main types that are employed today, and exactly how all of them work. Thanks very much for your time.
You know, many
Hello guys. So that's the basic principle of the operational of the geothermal. Okay. So we continue our lecture. Okay. So as mentioned just now, fortunately you are taking the power plant subject part, right? As a part of your elective. So it's a good combination of having the renewable energy. It's a part of the source of energy and yet try to implement in the approach or understanding for the power plant subject. Okay, so as mentioned just now, the basic principle more or less the same. It just limited in terms of the technology being used to harvest all the energy from the geothermal. Okay, so this is the geothermal harmful effect. I would say no, not harmful. Disadvantage. Harmful is quite harsh. Brine can salinate soil if the water is not injected back. It's not injected back into reserve after the heat is extracted. extracting large amount of water can cause land subsidence, okay, can lead to the increase of seismic activity. To prevent this cool water must be injected back, okay, reserve in order to keep the water pressure. For plant that do not inject the cold water back into ground can release H2S or sulfur rotten eggs, gas. Okay? With gas can cause problem if large quantity escape because inhaling too much is better. Okay? So that's the part of the disadvantages of implementation, the harmful effect. Do you guys any idea what is the advantages of the geothermal if we plan to implement? Let's say blessed by the area that capable to produce the geothermal energy. So do you think any idea what is the advantage of the geothermal if we are using that kind of source of energy? Anyone? Oh, so now we have 54 participants. Okay, so meaning that six, seven or eight students not joining the session. Okay, because in total we have 61. 61. Okay, never mind. Can anyone want to try? What's the advantages of having the geothermal in terms of the energy itself, maybe in terms of the economy, politics, social, technology, what else? Energy itself, unlimited power. Okay, correct. Okay, because uh, I will define the unlimited due to the consistency of the power because by having this kind of geothermal, regardless of day and night, regardless of the wind speed, regardless of the flow of the water, okay, as long your system can be running smoothly, you should be able to harvest all the hot water or steam to produce your electricity. Okay. So I've seen also the answer from our friend. Um, okay, unlimited, low maintenance. Okay, low maintenance. Yes, low maintenance because a very straight away to harvest all the hot water or hot air. Okay, correct. Thank you. Is it high performance as well? Yes, correct. Because a very the conversion is just the due to the um, heat exchanger. Okay, from the underground and then uh, we it reach to the heat exchanger to transform the heat to the cold water or the normal water, and then depends on you, how good your turbine is, the efficiency, everything. So you manage a higher efficiency of the turbine, so it should be you obtain the due to the conversion of energy. Okay, so it's a quite straightforward, right? Yeah, but the thing for the geothermal, of course, you need to invest quite huge number of initial costs. Okay, of course, and then you need to get that proper location, which is specifically the area or land site that capable to have certain piece of area to install all the facility and everything. Okay, so that's the drawback related to the geothermal. Then maybe we can see later due to the detail of the advantage. Okay. Geothermal positive attributes. Okay. Useful minerals such as zinc, silica can be extracted from the underground. Okay. So it's not only the heat. Okay. If you are going to drill all the water, everything, so you may have as well the mineral. Ultimately, it's a go home run. They will create jobs better. Okay. So by having the kind of facility, you you will attract the nearby community or resident to join as a part of the job. Okay, so offer a good job opportunity to the others. Okay? Yes, German company have signed 6 billion worth contract to build plant. And finally, okay, so you having abundance of energy resource by the first plant 8 to 4 cents per kilowatt, because it's almost competitive with conventional energy resource. Okay? So by having all the cost of tariff in terms of the per kilowatt hour, so you may go for 4 to 8 cents. Okay? 4 to 8 cents. Not 40 cents, not 80 cents. 4 to 8 cents. Okay? So that's the part. Your thermal plant can be online, okay, all the time. So I think this is the thing of related to the all the time. Okay. So sustain. Plant. Coal plant can be online 75%. Okay. Nuclear that's 69%. 1,000 to 2,000 less carbon dioxide. So meaning that it's a very clean energy in terms of the resource of renewable energy. Geothermal electric plant produce production 13.3 gram of carbon dioxide per kilowatt hour. Okay. Carbon dioxide emission per kilowatt hour for natural gas. So this is the saving of the harmful gases to the atmosphere, okay, by converting gram per kilowatt hour. Gram per kilowatt hour means that gram accordingly to the harmful gases such as carbon dioxide, okay, and then oil and something. Binary and hot dry rock plant have no gases emission at all. Okay. So meaning that there's no any harmful issue related to the hot dry rock. Geothermal plant do not require a lot of land. Okay. So 400 meters square can produce a gigawatt of energy for over 3 years, 30 years. Okay. So it depends on which kind of power plant you want to set up. So, but of course, you have the limitation by having the constraint of the space and the power you are producing. Okay. Geothermal heat pump. Okay. Heat pump 4 times energy that they consume. It initially costs more to install, but maintenance is cost is 1/3 of the cost for typical conventional heating, which is same like the Azim mentioned just now. Okay, so in that the maintenance cost is slightly low maintenance. It's just the matter of the initial cost. The initial cost means that the started you want to invest or to buy all the facility and equipment there. So it's quite high investment for the initial stage. But then after you complete all the things, it can be 1/3 of your cost of development. You can install with the help of special program that offer low interest rate. Okay, this depends. So let's say the particular company offer this kind of interesting package to be installed according to the program. So maybe they can offer you a good rate of payment scheme. Electricity generated by geothermal plants save 83 million use of geothermal prevent 103 million of fuel. Okay, so meaning that they're able to produce a quite relatively high in terms of the energy consumption, which equivalent to the ton or barrel of the oil, which is you may also lead to uh, okay. comparison of and so let's go almost like it the can you guys hear me? Hello guys. Okay, can everybody? Better? Okay, can. Okay. Thank you. Okay, we proceed guys. So just to show that this who is the major contributor of the harmful emission. In this case, coal, arang batu, coal. So of course, SO2, sulfur dioxide, and CO2, carbon dioxide. Okay? So that's why we try to reduce or eliminate this kind of percentage to ensure that our environment cleaner and greener. Okay? So I think this one is already covered during the video just now that we've been seeing. So basically, all this kind of effect been produced for quite some times, more than if the more, more than the 100 years. Okay. So that's the things we need to understand to ensure that we can appreciate the earth. Okay, or else maybe we produce harmful gases and everything. So we are no more longer to have this kind of the blessed country or the blessed earth. I mean, so we together we try to preserve by concerning all the effect to the environmental, specifically for our generation and our future generation. Okay, guys. So this one. So geothermal production is a third highest among renewable energy. It's behind hydro and biomass, but before solar and wind. Okay. So this one is a very general statement throughout the world. Iceland is one of the most countries successful in using geothermal. 86% of specific of geothermal city using the geothermal. Okay. So this is the application of the geothermal in Iceland. So this is the region that try to capture the utilization of the geothermal energy. Okay, so they try to pointing out this kind of, by having this kind of indicator. Red in color is the power generator. Green is the hot dry rock, okay, which is somewhere over here, also over here as well. Okay, blue direct use, okay, direct use also quite scattered all over the places. Okay, so that's the thing. Okay, so yellow is a World Bank project. So not all, as Sir mentioned just now, not all countries blessed with this kind of geothermal environmental condition. So we are the one who know this kind of information and need to have some sort of the good consideration before we try to implement those available renewable energy sources. Or else we will go for the very minimum, which will invest a high cost, which is not effective and not worth for the country, for the project itself. So we try to check this one. So install IS US. So that's why most of the um, example related to the US due to spend of thing. So they install 2000 megawatt and generate 15 gigawatt hour. So it's quite, and yet it's only 0.25% for the additional capacity. Just imagine, guys, this kind of volume is still not more than, not exceed 1% of the national capacity. Okay? So the rest is come from so other source of energy instead of the geothermal. So that's why it's the trend or pattern. Okay, so when we are making this one, we are still maintaining, identifying something, definitely increasing. Okay, so our neighbor in Indonesia, so also increasing. Australia, Australia 0.2. So that's the pattern of the surrounding out Thailand, also 0.3. So meaning that they have the things, they have the geothermal, but then not that much, 0.3.